All right, guys, let's go through types of reactions. My goal at the end of this is that you guys know by looking at an equation, there are 5 types of reactions. You should be able, based on what the reactants are and what the products are, that you'll know the type of reaction just based on what you see as far as reactants and products go. We're going to get to the point where eventually you will see just your reactants, and knowing how that works, you will be able to predict your products. So let's just start first, though, by let's just recognize the different types of reactions. So if you want to follow along with those set of notes, the set of notes that I gave you, combustion is the second one on your paper. It's the last one on my slide. So combustion's out of order for this one. But let's just go through. So reactions, the first one is called combination. Oh, I guess you can't see that. Hang on. Okay, so the first one is called combination. Okay, sometimes it's called synthesis, so it's synonymous. Both combination and synthesis, they can be called the same thing. I tend to call it synthesis, but I think it's all pretty clear in what the name is. Combination. What do you think is happening on the right-hand side? It's combining. I knew you guys were going to get that. So in combination, you have multiple reactants. Multiple reactants on the left-hand side, one single product on the right-hand side. So you will only get one product with a combination or a synthesis. So A plus B gives you AB. Okay, multiples into one. So again, when you are looking at your product side, your products, again, your rules for either ionic or covalent are the same. They'll combine in a certain way. Okay, we talked about yesterday. The example that I had, we had Na plus F gives you, or Na plus F2 gives you NaF. So that would be an example of a combination. But again, what you see on the left-hand side doesn't just automatically come together and then you're done. It's going to still combine in a way that all your ionic rules come into play, your covalent rules. That's why you balance. Okay. But if you look at an equation that has multiple things on the left-hand side, reactants, into one single product, that is going to be combination or synthesis. Okay. The next one is going to be decomposition. This is the exact opposite of what I just talked about. So you have one single reactant this time that's being broken down into multiple products. And usually there is some kind of catalyst that gets this going. You guys did a word example yesterday. That's still on the board. This would be an example of a decomposition reaction. Okay, decomposition means to break down. That's exactly what you're doing. So yesterday you had this potassium chlorate. It said it was heated. So in that case, heat would be your catalyst. It's not just going to randomly break down. There has to be something that makes it do that. So it's going to have some kind of catalyst that gets it to start the reaction. So decomposition, one thing into multiple things. So one product or one reactant into multiple products. The exact opposite of combination. Okay, so you'll know combination by many into one. You'll know decomposition by one into many. Okay, those are the easiest ones to identify. Okay, the next two are a little bit more involved, and we're going to talk about this as we continue. So there's 2 types of replacement reactions. The first one is a single replacement. So if you look, you have A plus BX, and on the other side, you have AX plus B. So A and B just flip-flop. It is a single replacement. So whatever your single element is, okay, it will always be a single element or a simple diatomic. So it's going to be one single thing, Na, for example, or it could be like Br2 or I2 or any of those diatomics. So it's either going to be a single element or a simple diatomic, and then you're going to have a compound. Okay, so that compound is going to be what is going to be switched in and out of. So in single replacement, you have your single element is a more reactive element replacing a less reactive element. And we're going to talk about this more tomorrow. We're going to go into depth on single replacement tomorrow. Okay. For now, I just want you to be able to identify it. But there's a chart that you have to look at. If the element that's by itself, if it's more reactive, it will go ahead and replace that part of the compound. If it's not more reactive, then no reaction actually occurs. Okay, and we'll talk about that a little bit more tomorrow. So there's a couple different types of single replacements you can have. You can have a metal replacing metal. Okay, so that would be an example where your single element is a metal, and then you have in your compound, remember metals in a compound always come first. So your metal here would replace your metal here. So the first two would just flip flop, which is what you see here, metal replacing metal. Okay. And again, the one that's doing the replacing, the one that's on its own initially, it has to be more reactive in order for it to do that. So you've got a metal replacement. Okay. This would be an example of that. Lithium is a metal. Okay. Sodium chloride. Sodium is my metal. So on this side, you have Li that takes the place of Na and then kind of kicks out Na by itself. So this would be considered a metal replacing a metal replacement. Okay. The next type you can have is a halogen replacing a halogen. Where are your halogens located? Group 7. Okay, so your halogens replacing a halogen, meaning your single element is actually it's going to be a diatomic because fluorine, chlorine, bromine, all of those are diatomics. Those are your halogens. So you're going to have a simple diatomic. Okay, so in this case, here's my example. Okay, Cl2 is going to replace Br. That's the only one it can replace. Cl2 can't replace K, okay, because at the end, that would leave me with two nonmetals together, and that can't happen. So you're going to have Cl2. The only thing it can replace is Br. So if you have a halogen, a diatomic out here, you're going to only be able to replace the halogen in your compound. Also, notice that when you kick out that other one by itself, okay, when I go back to metal replacing metal, La or Li is fine by itself. When it kicks out that Na, it's fine by itself. But most of your halogens are going to be your diatomics. So if it kicks it out by itself, it's not just going to be Br. It has to be Br2, okay, or Cl2 or I2 or whatever halogen it is. So just kind of keep that in mind. That'll come into play again more when you're predicting. But just know that if it's by itself, it has to be that 2, that Br2 or whatever the diatomic is. Okay, so metal replacing metal, halogen replacing halogen. And the last one is hydrogen. And hydrogen can do a couple different things. And again, I'm going to give you the chart tomorrow, and you just have to look at the chart to see. But a metal can replace hydrogen. So here is an example where, it's not metal replacing metal because hydrogen's not a metal, okay? But it does come first in that compound. So zinc is my metal, and then hydrogen this is an acid, okay? So that zinc and that H are going to flip-flop places, and then that H gets kicked off by itself. But that H is a diatomic, so it would be H2. All right, so this would be a zinc and hydrogen. So it's easy to see what they are. If you have two metals, it's metal, metal. If it's halogen, it's halogen, halogen. If there's a hydrogen involved, it'll depend on where the hydrogen's bonded to, okay? But regardless, those are your 3 different options. So single replacement, you have one single element or diatomic replacing part of your compound, okay? Single replacement. And then the last type of replacement is double replacement. Double replacement, you have 2 compounds, okay? So all of these so far are different enough that you should be able to just look at your reactants. In a combination or synthesis, you had multiples into only one product. In decomp, you had one product into multiples. In single replacement, you have one and a compound, and then in double, you have 2 compounds. So they're all different enough that they are distinguishable between all of the types of reactions. So your positives are just going to flip-flop. Okay, so A is with X on the reactant side. On this side, A is with Y. So A and B just flip-flop. Okay, and again, you'll have 2 compounds on either side. It's just your metals in those compounds are going to flip-flop and to have new partners on the other side. Okay, so I'm not going to talk about precipitate right now, other than here's an example of, here's diatomic. I have 2 compounds, the K and the PB, they're going to end up flip-flopping. So now K is with NO3, PB is with I. So that's just a visual example of a double replacement reaction. And we'll talk about precipitates later. Okay, the last one I want to talk about is combustion. Okay, so combustion is always going to be some type of reaction in which you have something being burned in the presence of hydrogen. Okay, there's a couple different types of combustion you can have. In this case, you have something being burned in the presence of hydrogen. You always get energy, always. That's why a lot of combustion reactions are the explosion reactions, because that's a lot of energy. So this would be an example of combustion. You have something in the presence of oxygen. A lot of times, too, you can have a hydrocarbon. What two elements do you think are involved in a hydrocarbon? Hydrogen and carbon. 2 for 2. 2 for 2. Hydrogen and carbon. So again, a lot of them, these you'll see a lot less. This is what you tend to see mostly with combustion. You have some kind of hydrocarbon. Hydrocarbons being, some kind of fuel, gasoline, propane, methane. Those are hydrocarbons. And then you have them being burned in the presence of oxygen, okay, O2. Your products with combustion, when you have a hydrocarbon, are always carbon dioxide and water, okay, and energy. But carbon dioxide and water every single time. So make sure that you have that written down for combustion. Carbon dioxide, water, energy, always, okay? Always. So combustion are the easiest to predict what the products are because it's the same products every single time, carbon dioxide and water, okay? So some kind of hydrocarbon in the presence of oxygen producing carbon dioxide, water, energy, okay? Questions on any types of those reactions are all pretty straightforward as far as like identifying them. Yeah, Eddie?
Can you have like multiple reactions in a single equation? So like can you have like a synthesis and a combustion?
Of the two, that would probably be the one that you could see together, synthesis and combustion, but for the most part, no, they're going to be they're different enough that they should separate themselves out. Yeah. Combustion's a little bit different. Synthesis would be the one that I could see that, depending on what it is. Because like in that first example, combination, the energy not necessarily written in the equation, but for the second example, you're not going to have one single product because you have carbon dioxide and water. So it depends on the type of combustion you have. Most of them are going to be different enough that they'll differentiate though. Yeah, good question. Any others as far as reactions go? Okay, let's go through a couple examples. Together. So we're just going to do this together. You don't have to, this isn't homework or anything, but let's go through. And again, just based on what you see, reactants versus products. All right, I know that it asks about balancing. We're not going to balance, but let's go through the first couple just to practice a couple together, and then I'll have you guys finish it for a minute. We'll go through it real quickly. Number one, you have NABR plus CaOH2 reacts to give you CaBr2 and NaOH. What type of reaction is that one? Double replacement. How do you know?
Because that's switching the negative to the positive.
Yeah, you have two compounds. You have two compounds, and the positives flip-flop. Okay, Na and Ca flip-flop. What about the next one? I have NH3 plus H2SO4 gives me NH4 to SO4. Synthesis. Multiples into one. Round number 3.
That's
That one's combustion. Combustion are the ones that you tend to have really high coefficients with. Okay, combustion is because there's a lot of hydrogen, carbon, a lot of energy going on there. Okay. Number 4, what type of reactions? Number 4? Single replacement. Good. All right, I feel like you guys have a good grasp on this. Take the next 3 minutes. Go through this really quickly in the next 3 minutes. Just tell me the type of reaction that it is.
Duncan.
Good morning.
You need carbon. And the next one after that. I'm sorry. You're not gonna believe it, so I think it's double. Yeah, you need hydrogen, but there is a carbon in the hydrogen. First one. Single.
We all know you do it for the day.
Yeah, no, there's like 4. That's scary.
Oh.
Oh my God. That is awful. So